Hey kids, it's Mrs. Van Dyke. Thanks for being my guinea pigs. We're going to try out flipping the classroom. You get to be the first ones. So, let's get started. In class, you got these notes, probability of simple events. So we're going to pretend like we're in class, and you're listening to me and filling in the notes and solving some problems as you go. At any time, please pause the video if you need more time to complete the problems or work things out on your own. Let's try it out. So starting this chapter on probability, what is probability? It's the chance an event will occur. The chance an event will occur. A simple event, what we're starting with, is either one outcome, one thing happens, one outcome, or a collection of outcomes. Generally, what we're doing is simply one outcome. So what is an outcome? An outcome is the way something turns out, or in math, it is a possible result of a probability experiment. Result of a probability experiment. Outcomes occur at random if each outcome is equally likely to occur. In other words, the chance of each outcome is the same. Or in other words, it's fair. Complementary events are two events in which either one or the other may happen. Either one or the other may happen, but they cannot happen at the same time. For example, when you flip a coin, the two possible outcomes are either, of course, heads or tails. If you add the probability of an event and its complement, then the result is 1 or 100%. So in other words, if you flip a coin, you have a 50-50 chance of it being heads, you have a 50-50 chance of it being tails. 50% either way, 50% plus 50% equals 1 whole or 100%. So we've got a whole chapter on probability. Who uses probability? Well, there's an entire city in Nevada that's concerned with probability, so people who gamble. It's all about probability. In everyday life, you might hear, what's the weather forecast going to be? That relies on probability. Many people, maybe your parents have a job in insurance that relies on what are the chances of somebody getting hurt or the chances of somebody getting sick. And you might be able to think of some more. A little bit more in terms of vocabulary. The probability of an event is the ratio that compares. This is going to be like a fraction. So the number of favorable outcomes goes in the numerator. The things that we want to happen, or the things that make us happy, number of favorable outcomes out of the total number of events. What do we want to happen out of the total? When you see problems in probability, you will see this abbreviation. P stands for probability, and then you'll see parentheses and the events that we're hoping will happen inside the parentheses. Once again, which means, what's the probability of this certain event happening? As always with fractions, we always simplify a ratio or a fraction. So let's get started. Working with probability, we see a lot of spinners. So here's our first spinner. The spinner is shown as spun once. Find each probability, write each answer as a fraction, a decimal, and a percent. So we remember how to do that from the last chapter, right? First question, what is the probability of spinning a C? How many C's are there on the spinner? 1 C. We're going to be writing a fraction based on this definition here, the number of favorable outcomes out of the total number of events. So how many possible things could happen when we look at the spinner? It's broken into 6 sections, so this is 1 out of 6. we always assume that what we're trying to get happens. So 1/6 of the time, we should spin a C. Now, let's change this fraction to a decimal. We divide, going down, show your work, put a decimal point behind the 1, add as many zeros as you think you need, and start dividing. I'm noticing a pattern here. The 6's keep repeating, so 0.16 with the repeating bar over the 6. Changing decimals to percents, we move the decimal point over 2 spaces to the right, always 2 spaces. You can keep the repeating bar in your percent if you'd like. So we have 0.16 repeating, and 16.6% repeating. You could also round it up to 17%. That would be fine. Remember, if I'm going too fast, please pause the video and take your time to complete it yourself. Let's try the next one, number 2. What is the probability of spinning a G? How many G's do we see on the spinner? I see none. 0 out of 6. So what does that equal? 0. And 0%, of course. It's all 0. Let's try another one. Number 3, what's the probability of a M or a P? So we need to add up the total number of M's and P's. I see 2. 2 out of 6. As a reminder, we simplify. So reduce that to 1/3. If you don't remember what 1/3 is as a decimal, then you would divide again, but this is 0.3 repeating. This is one of those ones that we should be very familiar with. And as a percent, move the decimal point over 2 spaces to the right. 33.3% repeating. Let's try number 4. What's the probability of 3 things happening? A B, an E, or an A? I know you're good counters. 3 out of 6 could happen, could land on a B, E, or an A. Reduce that to 1/2, which is 5/10 and 50%. Now, something a little different. What's the probability of it not landing on a vowel? So, in other words, what's the probability of it landing on a consonant? That would be B, C, P, and M. 4 out of the 6, or 2/3. As a reminder, take a look at our answer for number 3. If 1/3 is 0.3 repeating, and 2/3 is double that, then this should be 0.6 repeating. 66.6 repeating percent. Again, you could always divide and you should get the same results. And our last one on this page, what's the probability of it not being an M? So 5 of those are not M's. 5 out of 6. And let's do some long division here. Put a decimal point, add some zeros. Remember, the cowboy goes in the house, the horse stays outside. I'm starting to see some repetition. These 3's are going to repeat. This is 0.83 with the 3 repeating, or 83.3%. Let's flip to the back side. In probability, you also see a lot of number cubes mentioned. A number cube is the same thing as a dice, with numbers 1, 2, 3, 4, 5, and 6 on it. Find each probability. Write each again as a fraction, a decimal, and a percent. So consider all the numbers we're dealing with. We've got 1, 2, 3, 4, 5, and 6. What is the probability that you will roll an odd number? Well, that is 1, 3, and 5. So half of them, 3 out of 6, or 1/2 as a decimal and as a percent. What's the probability of getting a number greater than 4? That would be 5 and 6, so 2 out of those 6, or 1/3. And we have 0.3 repeating again. How about prime number? This one might be a little tricky. How many of those numbers do you think are prime? Count them up. The answer is actually 3 of them. 1 is not a prime number, but 2, 3, and 5 are. So those are numbers that have only factors of 1 and itself. So 3 out of 6, again, we're back to 1/2, which is 5/10 and 50%. The probability of rolling a 1 or a 3, there's 2 of those, or 1/3. How about number 5, the probability of it not being a 5? If it's not a 5, it must be 1, 2, 3, 4, or 6. 5 of those 6. And I remember this fraction from the last problem from the other side of the page. So I don't need to recalculate. And the probability of it not being an even. Well, if it's not an even, it's an odd. I feel like we already did that problem in number 1. 3 out of the 6 are odd or not even. Okay, just a little bit more. So complementary events typically was mentioned on the first page. Complementary events are 2 events in which either one or the other may happen, but they cannot happen at the same time. So some examples now. A number cube is rolled. What is the probability of rolling a 3 as a percent? So we know that that would be 1 out of the 6 possible numbers. And I remember this decimal from the other side, 0.16 repeating as a percent. How about this time I round it up to 17%? Why not? 17%. Now what does this say next? The probability of rolling a 3 plus the probability of not landing on a 3, what must that equal? Well, the probability of getting a 3 was 17%. Not landing on a 3, that would be 5 out of 6 numbers, or 83%. If I round. So 17% plus 83% of not landing on a 3, well, all possibilities add up to 100%. The probability of not landing on a 3 is 83% and is the complement, kind of like the other half, the complement of landing on a 3. The other portion. Either one event happens, I land on a 3, or it doesn't. I land on something else. So these always add up to 100% complementary events. Let's try one other one with a deck of cards now. A deck of cards contains 52 cards total, 13 of each suit, hearts, diamonds, clubs, and spades. So 13 of each of those. 13 times 4 equals 52. What's the probability of picking a heart if I had a whole deck? Well, that would be 13 of them out of the 52, or I could reduce that to 1/4. That is 1/4 of the deck. What's the probability of not picking a heart then? That would be all the rest of them. Let's see, 52 minus 13 is 39. 39 out of the 52, which of course must reduce to 3/4. They're both divisible by 13. These add up to, well, 1/4 plus 3/4 would be 4/4. They must add up to 1 whole. They are 1 whole or 100%, depending on how you want to answer it. They are complements of each other, one or the other. If anything went too fast, please replay this video. And we are going to talk about this and have some probability fun tomorrow in class. Thank you.